Hello friends, now we will see about the non-deterministic finite automata, that is NFA, right? What is DFA and what is NFA means? DFA and NFA are the two different types of finite automata. In DFA, for each and every symbol we are having exactly one transition. We are exactly having only one transition for each and every input symbol from each and every state. But in DFA, that is the transition is not like that. The transition means that is, here we are saying the del of Q0 comma 1. Consider this as a transition. If this transition is in DFA means it is equal to only Q2 or Q3. Exactly it is equal to a single state. Right? This is in DFA. But in NFA, the arguments are same. That is a state comma input symbol that leads to 0, 1 or more states. Right? That leads to 0, 1 or more states. That is, there is no transition for the symbol 1 from the state Q0, or it is having only one transition, or it is having more than one transition. Either it is equal to pi, or it is equal to a single state Q2, or it is having two transitions, that is Q2 comma Q3. Like this it is having more than one transitions also. This is the major difference between DFA and NFA. That is, DFA it must be present at only one state once. But in NFA it may be present at either 0 or 1 or more number of states. That is formally how we are saying. If there is no transition like this from the state Q0 for the input symbol 1, there may be no transition, that is 0. Or it is having exactly one transition, that is to the state Q2. Or it is having more than one transition like this Q2 comma Q3. Q0 comma 1 leads to Q2, and also it is having one more transition to the state called Q3. Like this, it can be, the transitions can be defined in NFA. But the formal definition will be same, that is M is equal to Q summation del Q0 comma F. This is common for both the DFA and NFA. Both DFA and NFA, the formal 5 tuples are same. Finite set of states, finite set of alphabets. Q0 is the start state and F is the final state. The only difference is how we are defining the transitions. In DFA, there must be exactly only one transition for each and every input symbol from each and every state. But in NFA, there may be, the transitions may be 0, 1 or more. That is the major difference between DFA and NFA. Right? Consider an example how we will construct an NFA. That is, for example, for what problem we are constructing the NFA means, the NFA has to accept the set of string, right, that is exactly having 1 in the second last position. That is having 1 in the second last position. 1 in the second last position. Construct a second last position. 1 in the second last position. Construct a NFA that is having 1, symbol 1. Symbol 1 in the second last position. Second last position means, if it is having 1 in the second last position means, after this 1 what should we have? Either 0 or 1. After that 1 we are having either 0 or it is equal to 1. It is equal to 0 or it is equal to 1. But the second last position it is having the symbol 1. Before this one, right? Before this one it is having 0 comma 1 whole star. Any number of zeros and ones in any sequence followed by 1. After this 1 only we should have a single symbol that is equal to either 0 or it is equal to 1. Then how we will construct an NFA for this condition? Consider this 1 is in the middle intermediate state, right? 1 in the second last position means, consider this as the last position. This as the last position's transition. That is, for this 0 or 1 we are having using this transition. Before this we have to make transition for that second symbol 1. That may be considered as the start symbol also. That may be considered as the start state, that is Q0, Q1 and Q2. Now Q2 will be the final state, and here the last one is either it is equal to 0 or 1. So we are having transition for this line. From Q1 to Q2 we are moving for either 0 or for 1. There is no restriction on 0 or 1. But the restriction is the second last symbol is exactly equal to 1. Second last means this is the last position, first last, and this is the second last position's transition. Right? So it is equal to 1. It is equal to 1. Second last position's transition input symbol is equal to 1. So it is equal to 1. Before that, before this one, it is having any sequence of zeros and ones. Any sequence of zeros and ones means that can be represented by using cell transition. Right? Here we are having a cell transition for the input symbol 0, 1. That is, any sequence of zeros and ones can be represented by using this transition. After that, this is for representing the second last one. Second last position symbol, that is equal to 1. After that, it is having either 0 or 1. After this one, it is having either 0 or 1. So for this, we are making transition from the intermediate state to the final state. Right? Now this is an NFA. If you are constructing a DFA for this same condition means, next what we have to do? We have to consider the remaining transitions. What are the remaining transitions for this? The transition for the state Q2. Right? We have to make the transition from the state Q2. And what are the remaining transitions left? We have to consider that and all. But in NFA, we need not to consider about the remaining transitions of the state Q2 and all. But here one thing is, we are having two transitions for the symbol 1 from the state Q0. Already we are having transition from Q0 for the symbol 1 to the state Q1. And again we are having a transition for the same symbol 1 from the state Q0. That is cell transition. Here we are having two transition for the same symbol 1 from the same state Q0. Hence it is an NFA. Right? This is the major difference. This type of transitions will not be present in DFA. Only it is possible in NFA. Right? Then how we will define this particular NFA? The 5 tuples are same. M is equal to Q summation del Q0 and F. Here what is Q? Set of states. What are the set of states here? Q is equal to, here we are having 3 states, that is Q0, Q1 and Q2. And what is summation? Summation is equal to 0, 1. And what are the transitions? Here we need to define all the transitions, all possible transitions for all the states, right? Here what are the transitions we are having? First transition is del of Q0, 0. Del of Q0, 0 is equal to Q0, the self transition. Next one is del of Q0, 1. For del of Q0, 1, what are the transitions we are having? Q0, 1 is the self transition and another one is the transition to the state Q0. So it is equal to Q0, Q1. We are having two transitions. The first one is the self transition and second one is the transition from the state Q0 to the Q1. This is the major difference between DFA and NFA. This is the major difference between DFA and NFA. For the same symbol, here we are having two transitions, right? But this type of transitions will never come under DFA, right? And which one is this? And what is the next transition? Del of Q1, 0 is equal to Q2 and del of Q1, 1 is also equal to Q2. These are the set of transitions present in this particular NFA. This is an NFA, right? And what are the major difference means? The number of states present in NFA is always less than DFA. DFA is having some exponentially more number of states than the NFA. The major difference between DFA and NFA is, first thing is transition function and second one is the number of states. Transition function means for each and every transition that leads to only a single state in DFA, but NFA leads to 0 or 1 or more number of states. That is the first major difference. And second one is in DFA it is having more number of states, exponentially large number of states than in NFA. NFA is having less number of states than DFA, right? This is a formal definition of NFA. Thank you.